Okay, continuing with the example. What was our velocity at 0? And what do I mean by v of 0 with no arrow over the v? That's just the magnitude. If you write a vector quantity without an arrow, you're talking about its magnitude. I could put absolute value signs around that, but that's unnecessary by convention. This is speed. V of 0 is velocity. This is speed, which is magnitude of velocity. Well, we saw what V of 0 is. That's this, right? So, it's this, okay, which I'm guessing is about 9.2 meters per second. It's going to be 5.1 times the square root of 2. Square root of 2 is a little over 1.4. 1.4 times 5 is 9. That is 1.414, and it's 5.1. So I'm guessing it's between probably 9.1 and 9.2. I could think a little more deeply in that, but might screw it up. I'm not gonna. Close enough. Okay, also, what angle with respect to horizontal was V of 0? Well, theta is the arctangent of V0y over V0x. Arctangent of, coincidentally, same quantity divided by itself, which is the arctangent of 1, which is pi over 4, or 45 degrees. Now, if that trigonometry is not completely obvious to you, go back and review the trigonometry you had in the physics prep and stuff, okay? Because all this is right angle trigonometry. And you really have to have a total command of it. Whatever time it takes you to really upgrade that trigonometry, it's going to save you much more time in doing the problems, okay? There's no law of sines, no law of cosines, very little law of sines or law of cosines involved in physics, in first year physics. First application of law of sines and law of cosines comes along about March, when we're dealing with circuits and the harmonic, like sine wave, alternating current and stuff, and phases and phasors, okay? Also in optics. And you don't even really need it then, but we go ahead and use it. Okay, well, I might be forgetting something, but I can't think of another application you need it for. Anything but right angle trigonometry. So you got to nail right angle trigonometry. If you don't, you're going to end up nailing it within the process of the course, which is gonna end up taking you long, I think. Maybe not. Okay, well, back here. So we can determine all these. Now, what about the same thing for VF? What were V naught, VF, and the angle at the final instant? Well, now we already know that Vx at the final instant, and let's write down final instant, is 0.9 seconds. So we know the velocity is the final instant, the x velocity, the y velocity, so here's your equation for the y velocity. And that's going to be figure stuff out, 5.1 meter per second times 0.9 seconds minus 5 meters per second squared times 0.9 seconds quantity squared. Okay, that's going to be 4.6 meters per second minus, well, that's 0.9 squared is 0.81. 0.81 times 5 is a little over 4. So this should be negative. Something's inconsistent here. Since everything else is so consistent, I'm a little flim-flammed about this. Something might be wrong in the analysis, because this is not going to be consistent. The final y velocity is clearly negative. The thing was falling. It was below its high point. But I'm getting positive here. I get like 0.6 meters. I might have done something wrong at some point, so you get to go back and look at it, okay? Gee, everything's supposed to work out, come back, nice full circle. Now this is how you would get the final velocity, right? Plug all this in. Okay, well, I've been at this for a little while. I wrote the equation down mindlessly. I wrote the equation for the position, not for the velocity. Of course, I did that intentionally, hoping somebody would catch me. Okay. Can't tell behind your mask whether you're laughing or not. You should be. Okay. V naught y is this, and at the final instant, this comes out. So that is approximately equal to negative 3.9 meters per second. So that the final velocity is meters per second times your I vector minus 3.9 meters per second times your J vector. Magnitude of VF is this. That's about 25 and 16, 41, which is about 6 point, square root being about 6.5 meters per second. And the angle is the arc tangent of negative 3.9. Let's put the meters per second in there, but it'll divide out over 5.1 meters per second. And that's going to be a negative angle. That's, I'm going to guess about negative, actually that's, yeah, okay, hang on. Yeah, I would say it's maybe negative 38 degrees. Which means 38 degrees below horizontal, right? And of course it was below horizontal, so these equations work. They can analyze that motion, which in many ways is simple if you understand the equations of simple harmonic motion, of uniform accelerated motion, okay? But more complicated than what you had before. If you keep a track of the idea, if you just keep the idea in your head that this motion and this motion are independent, that's kind of the key. And my lab assignment does a pretty good job of giving you both an intuition and a set of mathematical tools, okay? More about intuition in the first assignment. By the time we're in the middle of next week, it's a little bit more about the tools, okay? So,